Japan's SLIM probe has just made history with its phenomenal touchdown on the moon. Japan has become the 5th country to land a spacecraft on the moon. The massive project, which was years in the making, featured new advanced technology that may revolutionize space exploration as we know it. But amidst the excitement, something dark and mysterious was noticed about the probe, something that has everyone talking. It turns out there was a lot more to this mission than the world ever knew. What happened to the SLIM probe on the moon? What secrets have been revealed about this mission, its true purpose, and its impact on space exploration? Join us in this video as we reveal everything about Japan's Moon Sniper mission. We finally found what NASA was hiding. On January 19th, the Japan Aerospace Exploration Agency, JAXA, landed its special probe, SLIM, on the moon. This phenomenal feat made Japan the 5th country ever to land a vehicle on the moon successfully. The project started as far back as 2005 with the idea of building a small lunar landing experiment satellite. By 2013, SLIM had been proposed as one out of 7 focus missions for the ISS. Fast forward to April 2016, SLIM became an official JAXA project, with Mitsubishi winning the award for constructing the spacecraft. The most important aim of the mission was to test a new landing technology. The project, if successful, would showcase a precise pinpoint landing technique that would greatly impact space exploration moving forward. SLIM's journey to the moon took about 4 months. The journey began with a ride along the Gray Imaging and Spectroscopy mission, XRISM. After separating from XRISM, SLIM changed direction, preparing to enter into lunar orbit. By December 25, 2023, it gracefully entered lunar orbit and rounded it off with one of the most perfect moon landings ever witnessed. Moon landings have always faced a major issue: landing at the right spot. The Smart Lander for investigating the moon was a concept that aimed to use new modern technology to carry out a perfect moon landing. The success or failure of the mission would tell if the space exploration community had a new way of landing perfectly on the moon or any other planet for that matter. The focus for NASA and other space agencies has long shifted from landing anywhere on the moon to landing exactly at a specific point. Thankfully, the mission came to a fruitful breakthrough on January 19th when the lander made a very precise, soft landing on its target location.
Japan just made history by landing a spacecraft on the moon with unprecedented precision. The spacecraft, called SLIM, was the first lunar lander to use vision-based navigation technology, which allowed it to autonomously recognize and avoid obstacles.
Charge. JAXA's ground team had to use backup batteries to deploy 2 rovers to take measurements of the lunar surface. In addition, the multiband spectroscopic camera, MBC, which was mounted on SLIM, was able to capture some images during this period. Due to the data collected from the device, JAXA was sure that the lander hadn't suffered any major damage upon landing, so they decided to leave the probe on the moon and wait until after the sun changed its angle to face the solar panels. Just so you know, 1 lunar day is 14 Earth days, meaning that if you were on the moon, it would take 14 whole days for the sun to rise and set. Initially, JAXA had planned to operate the probe for at least 2 weeks, taking advantage of the solar power. However, after the unexpected crash landing, all that's left to do is wait until the end of the lunar day. By then, the sun's rays would point in the direction of the solar panel, and JAXA would finally be able to harness its power for the probe. This procedure depicted by the Japanese in this mission has demonstrated that it is possible to make very precise landings on the moon. Not just that, they've also shown it is possible to make a soft landing on the moon, something that has proven difficult even for agencies like NASA. One thing NASA didn't do during its Apollo missions was to land on target. For example, Neil Armstrong and Buzz Aldrin suffered complications while landing the Apollo 11 lunar capsule. First, there were severe communication problems with the base, and then all sorts of alarms got triggered. Overall, it seemed like the automatic landing systems had failed, and Armstrong had to take manual control to land the module. Even then, they landed in a completely wrong location. The fact that Slim landed on target is actually a plus. Most attempts to land on the moon recently have landing, so much so that the rovers could still be deployed. Just to give you an idea, imagine what would happen if a rocket suddenly loses one of its engines mid-flight. Worst case scenario, it would crash and burn. Best case scenario, it would make an emergency landing in an immediate, convenient landing spot. But you see, although the probe lost its nozzle, it still landed right on target. This has earned Japan a very honorable position amongst fellow countries that have dared to explore the moon. So far, only China has made a successful moon landing in the 21st century. It's still a wonder why 21st century moon probes can hardly stick a landing, whereas 50 years ago, NASA was landing astronauts on the moon. Many skeptics have raised questions as to why this is, and some experts in the scientific community have come up with plausible new explanations. First, back then, there was a space race. The US and Russian governments were at each other's throats. Each country tried hard to prove its superiority over the other, and the space beyond our planet was the battlefield. NASA, fully backed by the US government, poured in tons of resources to create the best lunar capsules, rovers, and landers. Today, there isn't a space war. All nations that have completed lunar missions have done so simply out of curiosity or to carve a name for themselves in the history of space exploration. And so, the probes or space vessels of today are done using substandard materials to minimize costs. Moreover, most landers are built by private companies. Statistically speaking, landers built by private companies have a 100% failure rate on the moon. The ice-based Japanese lander, which crashed on the moon in 2023, is a good example here. Another factor that creates problems for landers and space probes is the moon itself. Communication on the moon is a big problem since the giant white satellite always interferes with radio signals. This causes serious problems and is mostly responsible for the cases where probes land in the wrong spot. Again, the lack of atmosphere on the moon makes it impossible for a craft to land with parachutes. Everything depends entirely on the engine. The pilot or control must find a way to gradually steer the probe to land while battling communication problems. Ultimately, if the probe is too heavy, a crash is inevitable. China's Chang'e 3 Lunar mission in 2013 was the first soft moon landing since Russia's Luna 24 in 1976. Most other landings from other countries like Russia have met a worse fate. And so, it was high time someone came up with a solution for all the landing problems. Luckily, Japan came to the rescue. Just so you know, the Japan Aeronautical Space Agency has been a long-standing partner of NASA. As such, there's no doubt that the new Japanese guidance system would come in handy for future NASA missions. The Artemis program, for instance, which is scheduled to host the next set of humans on the moon since the Apollo missions, is surely going to feature some of this groundbreaking technology. Crashers, some conspiracy theorists who have long believed in the existence of aliens on the moon, have proposed that these beings are responsible. However, all this is just mere speculation based on the mystery clouding the event. The actual fact remains unknown. All JAXA knows right now is that Slim's panels are facing westward. For now, nothing much can be done for the probe unless, of course, the sun shines on our dear probe once again. The only way JAXA can know what really went down is if they get to see satellite imagery from something like NASA's Lunar Reconnaissance Orbiter. But be that as it may, compared to most other 21st century moon landings, the Slim mission was a success. If nothing else, the level of precision executed during this mission has earned it a top rank in most lunar landings that had been done before. Now, the landing SES or targets were marked in kilometers. Even then, many hardly hit the mark. For this mission, however, JAXA measured the landing site in meters, and Slim hit the mark, deviating by just 50 meters. Again, at least Slim was able to deploy 2 experimental rovers and use as much onboard science equipment as possible before its battery ran out. The 2 rovers, named Lunar Excursion Vehicles, or LEVs, were unique in their own way. While LE-1 is a frog-like rover that moves with hopping movements, LEV-2 is a small ball that splits into a wheeled camera and waggles along like how sea turtles do on a beach. LEV-1 managed to communicate properly with ground stations and also received a test radio wave data transmission from its cousin. NASA is taking a bold step to fly this rocket, although it has never been adequately tested with such a heavy payload before. All of this goes to show that space exploration is evolving and becoming more interesting by the day. With Japan's state-of-the-art landing technology and NASA's outstanding quality probes and launches, there's no doubt that the future looks bright for upcoming space missions. This begs the question: did Japan send a probe to the moon to explore the next-generation planetary landing technology? Or was there something more at play? Well, there's another obvious reason why the Japanese may have sent Slim to the moon: to explore space-based solar power. On January 11th, the United States Space Agency published a study examining the possibility of setting up solar power collection through a spacecraft in Earth's orbit and beaming that power back down to the surface using microwave. The goal here would be to create a source of clean energy. Even though the actual costs involved in the manufacture and launch of these systems are still being speculated, many experts are considering it. Thank you for watching another episode of Astrolumen. While you're still here, click on the video on your screen to see more mind-blowing videos like this one.